Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 4, Lesson 12, Distributing Expressions. And today we're going to model and write equivalent expressions, so two expressions that have the same answer, right, using the distributive property, so distributing numbers throughout the problem. We're going to move from factored form, the factored form of the expressions, to the expanded form of the expression. So let's go ahead and get started with some examples. Okay, here we have 2 times a plus b, 2 times the sum of a plus b. Now, what we want to do is create an expression that is equivalent to this. Now, I'm going to actually kind of go in reverse. I'm going to show you the answer before I take you through the steps, because I want to kind of see, I want you to see where we're starting, which this is the factored form of the expression, and then we're going to have the distributive form of the expression. So basically, when we say distribute, the 2 is on the outside, meaning it's multiplying, you're multiplying a twice, or a by 2, excuse me, and you're multiplying b times 2. And so what you're going to end up with then is something that looks like this. 2a plus 2b. And they mean the same thing. They are the same thing. But we're going to look at a model here that kind of helps us get there. So if I have a plus b, how could I model that? Well, I may use a tape diagram, and I have a and b. Together you have a plus b, right? They're added together. The expression here, which is 2, basically saying we have a plus b twice. So then we're going to erase this and add more to it. So we've got a plus b, and we're going to add on a plus b. So again, we have a plus b here with a plus b here. We have 2 of them, right? We're multiplying by 2. You see that. How would the model look if we grouped like terms? Basically what I'm saying there is, think about this. If you go to McDonald's, you don't say, I'd like a cheeseburger and a french fry and a drink and a french fry. You might say, I want a cheeseburger and a drink and 2 french fries. You put the things that are the same together. So what that may look like if we wanted to group the like terms, might be something like this. We put the A's together, we put the B's together. It's the same amount of everything, it's just we've switched it around. So now here we have 2A, here we have 2B. Hopefully you're starting to see that, hey, those are these numbers right here. So then what expression could we write to represent the new diagram? We have it right here, right? We have 2a here plus 2b here. So then what can we conclude from this? Well, we can say that 2a plus b is equivalent to 2a plus 2b. Now, what if I asked you to solve this problem? What if we said a equals 3 and b equals 4? Can we solve it? Sure we can. Let's make a little room to write here. We can solve it in 2 different ways. Either expression, right? We'll write in blue. We'll write the expressions in blue. If I have 2a plus b, essentially I'm going to have 2 times, and then a is 3 plus 4 is b. I know that with PEMDAS I have to do what's in the parentheses first. So 3 plus 4 is 7. I end up with 2 times 7. That gives me my answer is 14. If I do it this style, which I'll do in orange, I have 2 times a, which is 3, plus 2 times b, which is 4. 2 times 3 is 6. 2 times 4 is 8. I'm adding them together. 14. You're going to get the same answer either way. Okay, let's do another problem here. Let's write an expression that is equivalent to double 3x plus 4y. Well, how could we rewrite that? Double basically means it's the same as multiplying by 2, right? So we could say 2 times 3x plus 4y, or we could actually go ahead and double these numbers 3 times 2 is 6. So we have 6x plus 2 times 4 is 8. 8y. So you can have this expression or this expression. All right, let's make a model here. We're going to say this is 3x and this is 4y. Now if we want to double that, that would mean we'd have to have another 3x and another 4y. So we end up with our model here. Now, can we combine like terms like we did in the last one? Sure we can. The x's and the y's can go together. And so we'll have something more like this. The two 3x's go together. The two 4y's go together. And we see, well, we've got 3x and 3x is going to be 6x. We have 4y and 4y is going to be 8y. And you basically see that you're putting together 6x and 8y. So we have 2 times 3x plus 4y, or 6x and 8y. Let's do one more example. Okay, we have 3 times x plus y. Let's go ahead and create a model. We're going to create an equivalent expression for this, but first let's create a model of what this looks like. So we have x plus y, but we're going to have 3 of those. So we have to have another x plus y, and then finally another x plus y. So you see that we have 3 of those. Now, by combining like terms, I'm going to go ahead and rewrite this instead of erasing this time. I've got an x, an x, and an x that can go together. And I've got a y, and a y that can go together. So we end up with 3x and 3y. And we remember that we are adding. So this expression up here is equivalent to this expression, 3x plus 3y. All right, we're going to stop there. We're going to go through some more examples together in class, work some of these kind of problems out together. Hope this has been helpful. You can always come back, rewatch, and look at some of these examples again. Thank you for watching, and we'll talk to you soon.